Feeling like taking a coffee break? So do I. What about we talk about scoped values, the third element delivered by Project Loom that brings a new model for ThreadLocal variables adapted to virtual threads. Scope values are described in a JEP 429. It's the third feature published by the Loom project, along with virtual threads and structured concurrency. For the JDK 20, Loom gives you a second preview of virtual threads, that's the JEP 436, a second incubator for the structured concurrency API, that's the JEP 437, and the incubator ScopedValue, that's the JEP 429. All the links are in the description. First of all, what is a ThreadLocal variable? Why do you need it? How can you use it? And why would Loom want to give you another implementation of this feature? Well, there are cases where you need to share some information between the different components of your application. And of course, the classical, I should say the canonical way to do that is to pass this information as an argument in your method calls. This way of implementing this works well most of the time, because depending on the size of your application and on the type of information you need to share, you may find yourself in some corner case. Suppose that some of the components of your application are developed outside of your team or your company, like third-party dependencies, that themselves have more third-party dependencies. Would you really want to share some of your application secrets, like security secrets, with such untrusted components? In a real world, you very often need to deal with untrusted code. And sharing sensitive information with this kind of code is not what you want to do. This is why this ThreadLocal variable mechanism has been introduced in the first place in Java 1.2 in 1998. And yes, that was a long time ago. How does a ThreadLocal variable work and how it can be improved? Well, first, a ThreadLocal variable is a variable of type ThreadLocal. ThreadLocal is a class. You can create one, and you should make it reachable from anywhere in your code, or at least from where it is needed. Usually, a ThreadLocal variable is declared as a global variable, something like a static field, for instance. Then, when you need to give a value to this variable, you just call set on this value, and when you need to read this value, you just call get. Simple enough. Now, the trick is the following. When you call get, the value you get is the value that has been set in your current thread. This is what ThreadLocal is about. So if you call set on the same ThreadLocal variable with two different threads with different values, then the two calls to get will get you the two different values. The value you set is local to your thread. And yes, this is exactly why these variables have been called ThreadLocal. Internally, a ThreadLocal instance manages a map where the keys are the threads and the values are the values you have set. This is a very convenient way of handling things on servers that are working on a model one thread per HTTP request, for instance, or one thread per database transaction. With such a model, you can easily handle the life cycle of your database transaction, begin, and then commit or rollback, all with ThreadLocal variables. All this technical code can be handled by your server, and usually it is, without cluttering your code with these technical things. This is a simple model that has been working well for years, but it has some drawbacks. The first one lies in the way this API has been designed. Because ThreadLocal's variables are in essence global mutable variables, it may be hard to check who is mutating them. It may lead to code that is hard to follow, hard to understand, and hard to debug. Not great. The second one lies in the fact that a platform thread is an expensive resource in an application. These threads are pulled in executors, and most of the time they are kept alive for as long as your application is alive. Your executor services are created when your server application is created and are never shut down. It means that because the thread never dies, your ThreadLocal variables may be kept alive forever. You can call remove to remove a ThreadLocal variable from this internal hash map, but it turns out that many people forget to do that, and that can create memory leaks in your application, which is annoying. So, ThreadLocal variables are global mutable variables that can create memory leaks, which is not great. But it may be even worse. Every time you create a new thread, this new thread checks for the current thread, the thread you are in, and by default copies all the ThreadLocal variables from this current thread to the new one. This is the default behavior, the one you get when you call new thread without any argument. So if you spawn new threads from one thread that has a lot of ThreadLocal variables, you may end up duplicating all of them, which may not be useful in your application. It may be a bug. And this bug will represent a significant memory footprint overhead in your application. So, in a nutshell, ThreadLocal variables have been doing the jobs for years. But now that we have virtual thread, or almost have virtual thread, maybe it's time to revisit this programming model. And this is exactly what scope values are about. If you are not familiar with virtual threads or just need to learn more about them, you can check the episode 12 of this JEP Café series. The link is in the description. There are three main ideas you need to have in mind with virtual threads. First, they are much faster to launch than platform threads, about 1,000 times faster. Second, they consume much less memory than a platform thread, about 1,000 times less memory than a platform thread. And third, they are much cheaper to block. All the details are in the video I just mentioned, so please go and watch it if you want to know more. The consequence of all this is that where you are limited to several thousand platform threads per machine, you can now have several million virtual threads on the same machine. What are the consequences for ThreadLocal variables? Well, first of all, ThreadLocal variables are fully supported by virtual threads, so they'll continue to work. Let me say that again, ThreadLocal variables just work with virtual threads. The most important thing with virtual thread is that they are cheap, so you do not need to pull them anymore. In your application, you can create a virtual thread to handle one HTTP request, and when you're done with this request, instead of returning that thread to a pool for later use, you can just let it die. And when you need to handle the next request, you can create another virtual thread. Remember that creating a virtual thread is cheap, so that's perfectly okay to do that. And the same for database transactions. That solves one problem we had with ThreadLocal, which is this memory leaking that may occur if you forget to call remove once you're done with a given variable. Because this ThreadLocal variable will be removed when the thread dies, this problem does not exist anymore. But it brings another one. If you have a million virtual threads and all of them have a copy of a bunch of ThreadLocal variables, then you may discover a memory footprint problem. If ThreadLocal variables were immutable, you could share the reference to them, but they're not, so you need to copy them. Okay, so let us step back and analyze precisely what do you need for your application? First, you need a way to share some information between some of the components of your application without resorting to method arguments, because the code you have may be untrusted and the information you want to share may be sensitive. Second, you need this way to be efficient memory-wise, and for that, sharing immutable information may be a good solution. And third, you want a bounded lifetime for this information to avoid leaking, memory leaking and information leaking. And this is exactly what scope values are doing. How can you create a scoped value? Super simple, just call new instance, that's a factory method on the ScopeValue class. At this point, you want to make sure that all the code that needs to read the value of this variable has access to it. So maybe you'll end up putting this variable in a static field of one of your class in the exact same way as for ThreadLocal variables. What you get is a variable, so now you need to give a value to this variable. Remember that for ThreadLocal, you could give a value, and this value was available from the current thread and all the threads spawned by this current thread. Scope values are more restricted. The value is available from the current thread and all the threads spawned by it, but limited to a method call. It works in that way. Let us create a callable that queries some server to get some information in the form of a string. You can launch this task using this pattern. First, give a value to this scoped value using the where method, and then call this callable by passing it as an argument to this method. This scoped value can then be read with a get from wherever you need it, but restricted to the execution of this callable. If you check if this variable is bound outside of this callable, the answer will be false. This scoped value is only valid within the call method of this callable object, and of course, all the code that is invoked within this call method. So you don't need to call remove anymore, and by the way, this method does not exist, and you should not be afraid of any kind of leak, whether memory leak or information leak, because the API now handles that for you. How can you read this scoped value? Well, all you need to do is call get on it, which means of course that you need to be able to read this variable, so it needs to be visible from where you need it. And now you need to be a little careful there, because calling get on an unbound scoped value will throw a no such element exception. So if you are unsure that this scoped value has been bound, you may want to check it first with a call to isBound. And there are two other methods that you can use if you need a default behavior in case this scoped value has not been bound. You have or else that can provide a default value, and or else a throw that can provide a default exception. As you can see, there is no set method. So once you have fixed the value of a scoped value, you cannot change it. Which is nice because there is no need to copy a mutable value anymore. That's better for the memory footprint of your application. Scope values are not bound to a particular thread. That's a big difference from ThreadLocal. Actually, you cannot set the value of a scope value in your current context. You can set it for a method call that you're issuing, and that's it. Either a scope value has been set for you from a code that is calling you, or it's unbound. So a single scope value may have different values in the same thread. Let us see that on an example. Let us create a simple scope value that is read by a runnable. If you just call run on this task, you will see that the scope value is unbound, which is expected. And now if you pass this task to the run method of a scope value, it will read the value that you fixed any number of times. And if you run this task again, in the current thread, you will see that it is not bound again. So the following code prints the following, which is expected. And you can see that no new thread has been created in this code. This runnable has been executed 4 times, and each time in the same thread. As for ThreadLocal variables, scope values are transmitted to all the threads spawned by the task executed in the context of this scope value. This task can spawn any number of threads. This number can be as large as you need, and these threads can be created following any of the available patterns. They may have been created with the old new thread pattern, the factory thread of platform or thread of virtual, the factories from the executors class, and there are many of them, or the patterns brought to you by the new Structured Concurrency API, another part of the project Loom. If you need to learn more about structured concurrency, you can check the episode 13 of the JEP Café series, where you can see the structured task scope object in action. In case you didn't get it, the links are in the description. Scope values are of course fully compatible with all these patterns, and because the variable you share is immutable, there is no need to duplicate it in memory, which is better for your application and your server. That makes it a much more efficient way of sharing information among threads than inherited ThreadLocal variables. 2 last things. First, as you saw, you can fix the value of a scope value in the where call of this class. It turns out that you can chain this method call, which is useful if you need several scoped values for your tasks. This pattern looks like the following: fix the values of your scope value variables, and then pass your runnable or your callable with the corresponding method. And second, you cannot change the value of a scope value once it has been fixed. But what you can do is rebind it locally. That is, you can launch a new task from within your task with a new value for an existing scope value. So in this example, the current task sees the value ABC for the scope value key, and the code from the method other query sees the value DEF. And with this, I'm out of coffee. So that's it for today. Talk to you soon.